Welcome to Investigating Electronic Tuners. In this activity, we'll talk about what an electronic tuner is, how they're used, and then you are going to turn into a human electronic tuner and then take that data that you've collected, place it into a program that then has your code node mimic an electronic tuner. This is going to be a great activity. For it, you just need the code node, your SparkView software, and 2 tuning forks of different varying frequencies. You don't want them to be the same frequency. If you're using the ones in the kit, teachers out there, students, make sure your teachers cover the frequency and the note of your tuning fork, because that just kind of takes away the challenge. So we don't want you to see those up front. All right. So let's get started. If you play a musical instrument such as a guitar or piano, you know how important it is to keep it in tune. Musicians use electronic tuners to complete this task. An electronic tuner is a device that detects and displays the pitch of musical notes. Pitch is the highness or lowness of musical notes and is directly related to frequency. The higher the frequency, the higher the pitch of the sound you hear. The frequency of sound is the number of vibrations that occur per second, and we measure frequency in hertz. So like other activities, the first thing you're going to do is collect some real live data. But I'm going to give you a gimme here for your initial program, because your challenge here is going to be to program your code node frequency output of the speaker to match the frequency of the tuning fork. That way you know what the frequency is that you're going to need to program later in your challenge. All right, so if you look at the screen here, I'm giving you the program. It's also in your student activity sheet to get started. So let me take us to SparkView. All right, so the program I created is pretty basic. It's just saying when I press button 1, I want the frequency of the speaker, the output, to be at 100 hertz. If I press button 2, it's going to go to 0. So it's kind of like an on and off switch that you're creating. What you're going to do is start at 100 hertz, and then you're going to tap your first tuning fork, and you're going to listen to the sound. You at home and in your classroom would hit this on the heel of your hand and then put it on the desk. That way you can hear it better. But here in the studio, so you can hear, I'm going to hit the heel of my hand, and I'm holding it up to my microphone so you can hear. Let's go ahead and click start so you can see what this is going to be like in the beginning. That's 100 hertz. That is not matching the frequency of my tuning fork. So you are going to play with this. Go back and forth. You will increase the frequency until the sound coming out of the speaker matches the frequency of your tuning fork. And don't worry if this gets a little too loud. If you're in a classroom with a lot of other students, you might want to spread out around the room so you can hear things a little bit better. All right, pause the video, do the investigation, and match the frequency of these 2 tuning forks to the output frequency of your code node speaker. Okay guys, welcome back. Hopefully you were able to match the frequency of your tuning fork to the output frequency of your code node speaker. Once you have those 2 frequencies set, I want you to do a quick internet search or ask your teacher to identify what each note these are. Because remember, electronic tuners pick up frequency, and then they also let you know what note you're playing. That helps people tune their guitars and their pianos. All right, guys, so your challenge is to create a program that follows these parameters. You're going to use both button 1 and 2 as the hardware blocks in your conditional statements. You're going to set the speaker output to match the frequency of tuning fork 1 and 2. You're going to create a method to turn off the speaker rather than just stopping your program. So you're going to be able to be very creative there. the program, you're going to also use your 5x5 LED array. And this is why you had to find out what musical note it is. You might have guessed it. I want you to use the 5x5 LED array to let the user know on the screen what musical note is being played with each tuning fork. And then you're going to test your program for accuracy by striking the tuning forks and making sure that the frequencies match. And then save or export your program so you can share it with other classmates to see how they might have worked through this challenge. All right, you now have your parameters that you need to follow in your program. You're going to pause the video and feel free to return if you would like to see a sample of my solution. All right, how'd you do? I'm sure you did really well. All right, so I'm not going to show you my code just yet because I don't want you to see the frequencies that came up. I want that to be a bit of a challenge for you, but I want you to see how this works. I was able to do it. I matched the frequency output of my tuning forks and was able to program that here in my code node. Let's see how I did. I'm going to click Start. When I click button 1, that is the frequency of a C, and I can test that. It's pretty cool to hear that those are exact. Then I'm going to click button 2. You hear the difference? That is an E. And the way that I utilize my program is I chose tilt to turn it off. So that was mine. I'm going to come over here in my code real quick and delete the output of the hertz. Don't want you to see that. Okay, so here is my program. I have button 1. When I push button 1, it is going to give that output that you heard previously. Now it says 0 because you're going to put your own in there. And then I use a 5x5 LED array just to show you that I had a C. Then I had to have an if-else. So if it wasn't registering that, it's going to be clear on the screen and no sound coming out. Then I use button 2 to do the same thing for the second tuning fork. So there's a lot of challenges in there. I'm sure you did a great job. You learned more about frequency and were able to output a pretty neat program. And you not only were a human electronic tuner in the beginning, you programmed your code node to mimic an electronic tuner, so people playing a guitar might know whether they have reached note C or E. Good work, guys.